This is an introduction video of a multi-stakeholder dynamic optimization method for system of systems development. The world is becoming more complex with the rapid development of communication and information technology. In air transportation systems, airlines, airports, regulators, and many other entities interact with each other to provide good quality air services. In defense acquisition systems, different services, programs, and projects interact with each other to develop effective military defense systems. These large and complex amalgamation of systems with interactions between people, technology, policies, and places are examples of what is known as System of Systems, or SOS as a short name. SOS can be categorized into 4 types based on the degree of control over the entities. Acknowledged SOS is one type of SOS that lies between SOS with complete central authority and SOS with complete voluntary systems. In an acknowledged SOS, there's an SOS manager or mission engineer with global objective and resources, but has only partial authority over the participants. For example, in a naval warfare scenario, the headquarters or a program executive office is partially in charge of 3 programs relevant to littoral combat capability. The goal of the headquarters is to maximize the littoral combat capability with the best combination of systems. However, the SOS participants maintain a large extent of independence on the objectives and decisions. In this given example, anti-submarine warfare program, surface warfare program, and mine countermeasures program, each of them has individual interest and target. Therefore, in an acknowledged SOS, the composition decisions are made by the participants independently and in turn compose the entire SOS. The decision-making process is further complicated by the temporal perspective. The SOS development is an evolutionary process responding to a dynamic environment. Therefore, the composition decisions are actually a sequence of decisions over time. That is, when making current decisions, you need to think of the future possibilities. For example, if you acquire a system having low performance with very high cost now, you may need to think about the possibility of cost reduction or technology improvement in the future. All these composition decisions depend on resources and are also constrained by the resources. The resources here refer to money, manpower, technologies, and so on. The resources can come from the SOS manager or SOS participants or external stakeholders. When the resources come from the SOS manager, the limited resources cause conflict between the participants. Each participant wants to get more resources for its own benefit. It can also cause conflict between current and future decisions. How many resources to be used now and how many resources to be allocated in the future. Without proper coordination, the resources could be wasted, and none of these stakeholders can achieve desired capability. Therefore, we need a coordination method to achieve efficient use of the resources. The goal of this coordination method is to approach an optimal set of multi-stage composition decisions in an ideal and hypothetical centralized scenario where there's an omniscient manager who controls and knows everything. But this is not an easy task. The temporally coupled nature of decision-making, the lack of authority of the SOS manager, and the uncertainties everywhere. All these factors increase the already existing complexities in SOS architectural decision-making. So, how can we address the problem? We we turn to the commercial world. In multi-divisional corporations, especially multinational corporations, each division has independent profit goals. They employ a policy instrument named transfer pricing to coordinate the benefit of different divisions and aim to maximize profit at the firm level. That is, when Division A provides product to Division B, what is the appropriate price that Division B needs to pay to Division A? The Organization for Economic Cooperation and Development provides specific guidelines for using transfer pricing. A more general term for transfer pricing is transfer contract that includes other perspectives in addition to price. We employ the idea and redefine the transfer contract. The structure is similar, but now the transfer contract is bidirectional. Whenever a participant selects a system to acquire, for example, a helicopter, it consumes some resources from the SOS manager. Then, this participant needs to send some amount of compensation to the other participants. Other participants act similarly. This compensation is the transfer contract, which can be interpreted as partial capability, or knowledge, or equivalent monetary value. For example, when the transfer contract is interpreted as partial capability, one way to provide the capability is to send the helicopter to another participant for providing service for some amount of time. With regard to the sequential composition decisions problem, we employ approximate dynamic programming. ADP is a well-recognized method for addressing complex multi-stage decision-making problems and uncertainty in operations research. It has many successful applications in industry. The key advantage of ADP is the use of approximation to replace exact future values that the decision makers don't know. A common approximation is using a function of available resources because of the important role of resources. Then, the values of transfer contract can be associated with the approximate future value. If the transfer contract I received equals the future value I'm going to lose due to the resource loss, then independent decisions made by the participants can approach a near optimal solution as in a hypothetical and ideal centralized case. The combination of transfer contract coordination mechanism and approximate dynamic programming is the multi-stakeholder dynamic optimization method, or MUSTDO for short. The key contribution of the MUSTDO method is to relegate the quantitative complexities of decision-making coordination to the algorithm, while delegating the decision-making and trade-off assessment to the SOS decision-maker within a coordinated quantitative framework. The method has been applied to the example of a naval warfare scenario. The yellow figure gives the cumulative capability comparison between 3 different scenarios. The darkest bar shows the best result that we can get when there's an omniscient manager who controls and knows everything. When the top manager only has limited authority and limited information, the MUSTDO method produces higher capability over 10 years than using the alternate method that distributes resources evenly. The blue figure on the left shows the values of transfer contract. We observe that the surface warfare program or SUW participant sacrifices the most for achieving the SOS level optimality. It seems unfair to the SUW participant. However, the transfer contract sent out by the SUW participant is the price for using the resources Otherwise, the SUW participant cannot obtain the resources that are needed for capability development. We have also applied the method to a distributed emissions allowance allocation problem, where the airlines make independent decisions about flight assignment when they are competing for the emission permits provided by the regulators. From the figure, the MUSTDO method produces similar results to an alternate grandfathering approach, but the MUSTDO method helps the regulators reduce the possibility of inaccurate allocation. It provides more robustness for uncertain change in the future, and also reduces the workload of the regulators. We have also developed a graphical user interface for the decision makers to use the MUSTDO method. If you're interested in the method, please find details in my paper and the dissertation. Plus, the MUSTDO method is one of the methods in SOS Analytic Workbench developed for supporting SOS architecting. Please follow the link to find all the tools if you are interested. If you have any questions or you would like to learn more about the methods and tools, please do not hesitate to contact Professor De Laurentiis or myself via email. Thank you very much.